It would help the brain focus in on the characteristics that make that partner unique. In other words, the individual says, wow, that felt really good. And I was with this individual when it happened. And therefore, I'm gonna try to be around this individual more often.
It's hard to imagine that a chemical cocktail of just 3 hormones could be the basis of bonding and love, that complex emotions could have such simple roots. But Jung had a strong hunch, and in a search for evidence, he turned his attention to other mammals in the animal kingdom and to a virus. Scientists have identified more than 4,500 mammal species on Earth. However, less than 5% form lifelong bonds. This short list includes some species of otters, jackals, dik-dik, and beavers. To investigators like Jung, most monogamous mammals prove difficult to study in the lab because of their size and the habitats they would require. But there are a few species that make perfect candidates. Prairie voles are among the most doting mammals on Earth. Like some humans, males and female prairie voles form lifelong bonds, share parenting duties, and males jealously guard females. In contrast, a nearly identical cousin has adopted a more swinging lifestyle. When the promiscuous cousins have sex, there are no strings attached and no cuddling afterwards. In fact, if they get too close, they're more apt to fight than to playfully nibble. What's driving these two distinct approaches to mating? And could the answer help us understand human relationships? When Jung peered into the vole brains, he discovered that both species were releasing the same love cocktail as humans. But there was one big difference between the vole species. Only the monogamous voles had sufficient brain hardware in the form of receptors that could soak up the bonding chemicals.
Hormones like oxytocin or vasopressin can only act by binding to a receptor. It's sort of like a key in a lock. But when we looked in the brain of the prairie voles, we found that these reward areas were loaded with oxytocin and vasopressin receptors.
The promiscuous voles have fewer receptors, and Jung suspects that could explain their free-loving lifestyle. To investigate his theory, Jung turned to a virus. His plan was simple. He injected a virus into the brain of a promiscuous vole. The virus sliced into the vole's DNA and inserted the instructions to create more receptors. Brain scan images revealed success. But would the new receptors change behavior? To find out, Jung mated the virally altered vole with a female. And then separated the couple. Next, he tethered the mated female in a box. At the other end of the box, he tied down a temptress. And finally, he introduced the virus-injected vole. Would the male remember the days in the love nest? Or would he be back on the prowl? In an evolutionary flip-flop, the virally altered vole returned to to dote on his mate. A virus that altered just one gene had dramatically changed their behavior. Again and again, with dozens of previously promiscuous voles, Young got the same results. Young's results are striking and raise provocative implications. Perhaps an ancient virus long ago entered our bodies and rewired us for monogamy.
Given what we know about viruses and what we've done in our own laboratory, I certainly think it's a possibility that a similar sort of thing may have happened in nature. And if it did, it could have resulted in changes in behavior, including the evolution of social bonding, monogamy, and perhaps even the emotion that we call love. People often ask, if we understand the biochemistry of love, won't that take away some of the magic? And I really have to say I don't think so. It's not going to ruin my sex life.
To Luis Villarreal, viruses are more than mere parasites. Yes, they can cause sickness and even death. But he's among a growing number of investigators that suspect there's far more to viruses than we ever imagined.
The notion that viruses could simply be harmful is absurd. Let's say you had a switch on the wall, and if you flip that switch, you can eliminate viruses on the planet. Many people might think, okay, I would flip that switch. But the reality is, if you did flip that switch, many of us who study viruses think that the world would come to a screeching halt.
Viruses not only are infectious and cause disease, ultimately what all this work will mean is that viruses most likely played a fundamental role in evolution.
Villarreal couldn't agree more. In his story, viruses gave rise to the first complex cells. Played a role in the diversification of life. Changed the way the young are born. Drove the wedge that separated us from our closest cousins. And may have given rise to complex emotion. Given the potential role of viruses in evolution, many are starting to question who we that could lead to, and they're not through with us yet. He knows that viruses are attempting to modify our species in a way.
I think it's really easy to come to the conclusion, and I'd come there, that we are viruses.
To Villarreal, viruses have clearly shaped our basic blueprint, new human beings. How will
suppose that this phenomenon could continue? It could lead to the creation of a new lineage of humans, a new species of humans, including primates and including hominids. And therefore, it's not at all difficult to production and diversification of all life on this planet. Viruses have had a major impact on the origin, evolution. It's clear that
viruses redraw who we are. What might a new human look like? How might they construct their societies, their culture, their art? What would it mean to be human? For viruses, the long march goes on.